Okay, here's some guidance for the homework for these two problems. These are really important because one of them is the model for what's going to be on the midterm. So think through these carefully. They're both essentially the same. It's just different material, different content, but same idea. Okay, so the first one, you got this test. Uh, 97% of those who have used illegal drugs within the previous week will get a positive test result. So the idea is that for the test, it's 97% reliable in terms of those who actually are drug users, illegal drug users, right? Not legal drugs, whatever that means. So for that, let's just say bad drugs, right? Again, whatever that means. 94% of those who have not used illegal drugs in the past week will get a negative test result. So there's two sides to the test. One, it's 97% reliable for getting a reliable positive result in terms of someone actually using drugs. Not all tests, in fact, pretty much all tests are never 100%, right? There's always some unreliability, but 97% for capturing those who really do use drugs and giving a positive result, that's pretty good. And on the flip side, it's not as good, but still pretty good. It 94% accurately relates those who have not used illegal drugs. So it's 94% reliable. If you're not a drug user, it'll say 94% of the time correctly that you are not. So you get a negative result. It's been reported that 1% of adult employees in this county uses illegal drugs. That's pretty low. So let's suppose you're in a good place, affluent, a lot of workers. 1% only are actual illegal drug users. Now the question is, does this test give you useful information about which of these adult users, adult employees is using drugs? So you think, oh, if it's 97% reliable for those actually using drugs and 94% reliable for those not using drugs, sure, shouldn't it give you reliable results? Well, let's document this. First, you diagram. So you got two sides. Either one, I, they're illegal drug users, or the other side, D, they're not drug users. Sorry, I changed this slightly. This should be I and not I, right? Doesn't use illegal drugs. Instead of D, you should have I there. Um, and you split this up, this initial branching, by the population. It's always whatever constitutes initially the 100%. In this case, you got a population. 1% uses illegal drugs. That's just 1% here. 99% don't. That's why I have D there, don't, but better labeled as not I. Okay? And then from that, you can get either two results. You can either get a positive result or a negative result. And from this second branch, a positive result or a negative result. P or not P, if you like. Negative result is the same as not P. I've taken off the not P here or the N, negative result, because you don't really need it. That's not what's being asked here. But when you diagram, you might want to include that information for yourselves, and only later do you figure out what question is being asked. So here's the second part. What question is being asked? The question is, what's the probability that given a positive result, they're in fact an illegal drug user? That's what you really want to know. Given a positive result, you want to know, are they really an illegal drug user? So how do you do that? Let's use Bayes. Remember, it's the first, so probably of I, times the flip, probably of P given I, divided by that same thing, right? Plus not I, the opposite, so in this case, that side, and then the flip, P given not I. How do you read that off the diagram? Probability of I is just 1%. I'm going to translate all this. I'm just going to move everything. I'm going to take away the percentage and just make this 1, 97, 6, and 99. It's just easier that way, okay? But you guys can do the calculation on your own. Remember, no calculators on the test, so you should practice on your own. You can start by moving your decimals and all that. I'm just making it easier, it's shorthand. So you get 1 times, and then the other one is P given I. Well, P given I just says given I right here. What is P? When you read it off the diagram, that's all that this flip represents, the second part of the diagram, 97%. Again, think about what that means. The flip is just P given I. Given I right there, what is P? Not this P right here, because you're given I, not that side. So it's 97%. So it'll be just 97. 1 times 97 is 97. Divided by the same thing plus The opposite. What is the opposite? Not I, which is in this case not an illegal drug user or doesn't use drugs. That's 99%. And then that's this part right here, 99%. So I just put 99 times the flip. P given not I. So given, in this case, D or not I, what is P? It's 6%. Well, I just multiply it by 6. And when you multiply it out, you get that number. You guys can do that calculation on your own. It turns out not to be that reliable. What this indicates is that even if you got a positive result, the chances that you are an illegal drug user isn't, it's pretty reliable, but not as reliable as you would think. So think about what that means. We'll talk about that in the very next lecture. And it has to do with what are called base rates. So for right now, we're just focusing on the diagramming and the calculation, and we'll talk about meaning and all that in the very next lecture. You can read that now if you want, if you're curious. Okay, the second one. Suppose a reckless, insurance company, right? It classifies people into two classes, reckless and not reckless. I should tell you up straight up. This stuff is the basis for how insurance companies and a whole bunch of other corporations and whatnot make decisions. We're going to get to this later in the course, something called decision theory. But it's basically the use of probability along with these branching lines and then other factors put in. So you got two sides, reckless and non-reckless. On the basis of prior experience, they look at records, data. They know that 25% of the population, let's suppose, it insures are reckless drivers, the rest are not. Right? They classify them as safe drivers. You get safe driver discounts, maybe. I don't know. Suppose that by experience, the company knows that a reckless driver has a 60% chance of an accident in a given year, a non-reckless driver only a 5%, right? Chance. If the company insures a person with no prior record, it assumes there's a 25% chance they're a reckless driver and set the rate accordingly. After 1 year, is it reasonable to modify, or it is reasonable to modify his premium based on the rate on the basis of his driving record? Okay, so what are you asked for here? One, what is the probability that the person's a reckless driver? Before you answer the second question, you got to do this. So here's the diagram. The population splits into two sides, either reckless or not reckless, right? 25% is reckless. That means 75% is not reckless. And then relative to that, you can either get into an accident or not an accident. Okay. Since they're only asked about accidents, that's the only thing that the insurance company is concerned about. If you don't get into an accident, they don't care. You just pay your money and you're fine. What are the probabilities then? Well, given a reckless driver, there's a 60% chance of having an accident. And a non-reckless driver, only a 5% chance of an accident, right? That's what their data indicates. So here's the question. Probability of being a reckless driver given you were in an accident. You want to know, again, what's the probability that a person is a reckless driver? So given an accident, what's the probability that the person's a reckless driver? So the Bayes formula is you take the first probability of R times the flip probability of A given R. So probability of R is this, 25% right there. I'm just going to translate all these into straight numbers, so just 25, and then flip it around. A given R, right? So given R, A given R is this part right here, 60%, which I just have as 60. And then you divide that by the same plus the opposite. So probability of not R, which is right here, 75, times the flip, probability of A given not R. Given not R, what is A there? That's 5%, and that's what you have here, 75 times 5. So solve for that, you get the number. It's a pretty decent number. So the idea is this gives you reliable information that given an accident, the chances that they're reckless is pretty good. So would it be prudent to raise their premium, charge them more? The answer is, if you're the person running the insurance company. On the other side, the answer is yeah. You want to, since they're a greater risk. Okay, so that's that. What we're focused again here is just on diagramming, asking the relevant probability question, using Bayes, and then solving. Again, you guys should all try this on your own, and then use this as guidance to clean up wherever you're not understanding. Okay, see you next time. Be sure to read the next lecture, which clarifies this, and then there's a review section in La Lima indicating the structure of the exam and what problems to practice. See you next time.